welcome to Algebra 2-1, Unit 1 through 4. Today we're going to be looking at conjugates. Conjugates are so cool, so easy, and so fun. If I call my complex number z, then I would represent a conjugate as a little line over the z. Be prepared for that. Now, in class we've been playing around with multiplying binomials, and you guys have already discovered what could cause two terms when you're multiplying binomials. And what does it is the conjugate, a minus bi. Okay, so here's some examples. 4 plus 7i, the conjugate would be 4 minus 7i. When we multiply those, again, it wipes out your outside inside, and so really it's just a 16 minus 49 I squared, but I squared is equal to -1, so it's 16 plus 49, which ends up being 55. So, as you notice, we start with a complex number. We end up with a real number for our answer when we multiply conjugates. There's a reason to that, and it's pretty cool. You're going to get to play around with that in class. So the conjugate here, pause the video, go ahead and do these, see if you get them right. This would be 5 plus 2i. So now that would be 25. It would become a negative 4i squared. That I squared becomes plus, so it's 29. Okay, now on these, I generally will put the 0 in there just for me to remember how the conjugate should go. So this would be 0 minus 3i, so the conjugate would be 0 plus 3i. It just helps my brain. You don't have to leave it there if it bugs you. But, oops, it was a minus. I promise it was. Okay, so it's a plus 3i. That would end up being a negative 9i squared, so positive 9. Okay, negative 6 plus 0i would be negative 6 minus 0i. So erase those, and we just have negative 6 times negative 6 is 36. Ooh, I have an awesome question. Is there any time when you would multiply a root by its conjugate and end up with a negative number? And I'll be honest, I don't know the answer, so you guys go search that out. I may even take pity on you and give you more extra credit points. Okay? Or candy. There's always candy. Okay, candy for the kids. Okay, imaginary and real can be plotted on a graph, and this really helps if you're looking for the absolute value of a complex number. Because this is your real. Maybe I should put a plus bi to remind you. The a is the real. So these will be your a. This is your imaginary. So the y will be your imaginary. It's that simple, guys. So if I'm going to plot 3 plus 4i, I'm going to go over to 3 on the real and up to 4 on the imaginary. And there's my point. Now, absolute value means distance from 0. So I want to know, how far is this from the origin? Well, you all took geometry, right? Does this look familiar? Find the hypotenuse. This is A, this is B. Do you remember doing this? So the absolute value of A plus BI would become A squared plus B squared equals this side, but then don't forget we need to take the square root. So we don't even care that it has an I in this situation. All we have to do is square, add them together and take the root. So we take 3 squared is 9. 4 squared is 16. Add those together, we get 25. Square root of 25 is 5. So we know that the absolute value of 3 plus 4i is 5. Okay, let's do another one here. 1 minus 5i. Let's plot it out first. It would go 1 and then it would go down to negative 5i. So it would be right here. I'm wanting to know that distance. I'll erase my old one. You can plot these anytime I ask you. It's cool. So this is 1, this is 5. So you're going to go square root 1 squared plus 5 squared. 1 squared is 1, 5 squared is 25. Square root of 26 cannot be simplified or reduced at all, so you would just say it's square root of 26. Okay, again, write down questions as you have them tomorrow in class. Go over those. Now, okay, now we're going to also remove this up here now that I'm done graphing. We're also going to divide. So, what's wrong with this just being the right answer? That would be my question. Can we just be okay with that? If you remember from Algebra 1, your teacher told you you can never end up with a radical on the bottom. And I is equal to radical negative 1. So, in other words, guys, no I on the bottom. Okay? How do we get rid of the I on the bottom? Well, if he's a radical, what's the only way to get him out of prison? Hopefully you're saying, oh, just bring his twin into prison. Shebang. So, we just multiply by, you can multiply by 2i or just I. I typically, if it's just an I there and it's a factor, I'll just multiply by I. Okay, so multiplying by I, that would become 2i squared. Up here, you would have to distribute, so it would become 6i minus 4i squared. Ta-da! I squareds become negative 1. And so now we have 4 plus 6i over negative 2. Distribute that. 4 over negative 2 plus, actually it shouldn't be plus because it's a positive 6i, whoa, what happened to my pen? 6i over negative 2i, and a positive and negative make negative. Or not over 2i, but over 2, okay? So, 2 will go into 4 2 times, so it's a negative 2. 2 will go into 6 3 times, so it's a negative 3i. Ask me lots of questions on those. That's how you do them, get rid of that I on the bottom. So now, of course, we come to a situation that's a little more challenging, and that is, what if we have a binomial down there? Well, can I ask you, how did you get rid of the imaginary number with these binomials? Conjugate! You guys crack me up. Okay, so the conjugate of this would be, oh, my pen is dying again. Hopefully this one works. 2 minus I. 2 minus I. What you do to the bottom, you have to do to the top. Now we already know conjugates, we're just going to end up with the first and the last because it wipes out the outside inside. So 2 times 2 is 4 minus I squared, which is 1. Negative 1, I should say. So 4 plus 1 is 5. Okay? Now on the top, you're going to need to either FOIL or box this. 10 minus 15i. times 2 minus I. Okay, let's see how well I can do this in my head. 10 times 2 would be 20. 10 times negative I would be negative 10I. Negative 15 times 2 would be negative 30I. Negative 15 times negative 1 would be a positive 15I squared, which would make that a negative. Now I put my real terms together. 20 minus 15 would be 5. Negative 10I and negative 30I would be negative 40I. Don't forget, each one's over 5 because we're just going to go ahead and distribute it. So that would become 1 minus 8I. Okay, now guys, I do a lot of these boards in my head because we learn the most by our mistakes. So if you catch something that you think is a mistake, please, please, please write it down accurately, write down the time in the video, and bring it to class, and we'll see if it is a mistake. Okay, next one. 1 over 2 plus 2I. Again, we want a conjugate here. It would be 2 minus 2I. Multiply the top by the same thing. And our conjugates, we end up getting 4 minus 4I squared, which would be plus 4. 1 times 2 is 2. 1 times negative 2 is negative 2I. Sorry, 1 times negative 2I is negative 2I. Okay, 4 plus 4 is 8. So we have 2 over 8 plus and a minus, sorry, not a plus and a minus, it's 8. So it's a negative 2I over 8. Okay, 2 eighths is 1/4. A negative 2/8I would be a negative 1/4I. And I just leave it just like that. Okay? See you in class.